Hello everyone, and welcome to Monash College virtual classroom demonstration. My name is Glenn Jennings, and I'm the Diploma Program Director at Monash College. I'm very pleased you're able to join us today to get a first-hand experience of our virtual classroom. While international borders remain closed, providing a high-quality education for all of our students remains our priority. And we're delivering this through blended online virtual classroom and face-to-face pathway programs. It's our commitment to provide new students starting their studies with us offshore with the opportunity of a guaranteed pathway into Monash University without slowing down their education journey. In addition, the completion of Diploma Part 2 allows students to transition to second year of their chosen undergraduate degree at Monash University. Our online environment is built on the same approach we use in our face-to-face classes. The same teachers, the same curriculum, the same support. In fact, we've actually strengthened our support model so that students receive tailored individual support from experienced teachers such as Dr. Tarek Shehata, who can help you with specific concerns. We also have learning skills advisors, counsellors, and student engagement specialists, all dedicated to supporting and encouraging our students. In today's virtual classroom taster session, one of our diplomas teachers, Dr. Tarek Shehata, will be taking you through an introduction to Engineering Design 1, lighter, faster, stronger. And you'll also be hearing from one of our current diploma students, Ke Ying, as she shares her experience in the virtual classroom. We'll also talk about the support services available to students to make sure you have the best possible experience with the college. Our team has one goal in mind: to give you a fantastic learning experience that sets you up for your undergraduate studies. So now I'm going to hand over to Tarek, and I look forward to you joining us in the Monash College virtual classroom, and then in the future, face-to-face on campus once the restrictions are lifted. Thank you very much, and over to you, Tarek.
Thank you, Glenn. Welcome, everyone. My name is Tarek Shehata. I'm glad to have you join us today for a sample class on Diploma of Engineering. I will take you through a virtual class tester and show you how we use Zoom to teach our lessons. Let me just share the screen. So our topic for today, it will be design of axial loaded member compression case load. This is coming from a subject called Engineering Design 1, and this subject under lighter, faster, stronger. And this is as an introduction to engineering. Okay, so when we talk about design, mainly we talk about three issues. Either as a designer to determine the size, so to talk about area or dimensions, to say this part should be in this size, or to select the material, to say based on the required sizes and the loads, we are going to have this material, so you can say steel, wood, aluminum, and so on. Or as a designer to check the performance of the member. Last week, we was talking about the member under tension, and we said last week, the load, when we describe it as an axial load, we talk about the load to be through the axis of the member. This is why we call axial loaded member. Last week we finished tension, so today we are going to talk about what about compression. So In the case of compression, or let's review what we did in tension last week. We said the main condition for the tension that based on how much load I have and what is the actual area, I can calculate my actual stress. And to be safe in tension, you need the actual stress to be less than or equal to the yield stress. Yield stress, this is one of the material property or the material properties. Today, we are going to talk about the axial load. So in this case, we'll talk about compression. And mainly today, we are going to concentrate on how to use Euler equation. So member under compression, axial load, as you can see in the figure here, I have the member in the shape, doesn't matter what is the shape, I selected a cylindrical shape. So the load itself, P, compress the member in the direction of the X of this member. So in this case, we worry in our design this member to fail. Member will fail due to compression because of two things, either squashing, so the load will squash the member, or the member will be buckled. And buckling, it's meaning the member not to be broken, but it could be bended, something like that. So buckling, one of the things, the member will be bent. I have another picture to help us. Not broken, but it will be bended. Last week, when we discussed the tension, the case of squashing is similar. So what we did in tension, it will be the same for squashing. You check how much stress you have and how much actual stress to compare with, how much yield stress, then to compare based on if your actual stress is smaller than or equal to the yield stress, the member is safe. If not, the member will fail. But today we wanted to discuss the case of buckling. Buckling is controlled by equation called Euler buckling load. This equation can tell us what is the maximum load based on the properties of my member. So if I have a member made of a certain material and E here to represent the Young modulus of this material, this is material property. I to represent weakest second moment of area or moment of inertia of this member, and I to be calculated based on the area divided by the length effective square. This term may be new. We have, soon we will talk about it, but we have the length, and this is again part of the dimension of the member. So in this case, you will find Euler linked some elements related to the material properties, like Young modulus, and some elements related to the dimension of my member, like I and L. What is the condition? You need to have your load not to exceed the load calculated by Euler. What's the meaning of that? Euler is the maximum load to be carried if you have this member. So this is the condition. If your load will exceed Euler, P Euler or Euler load, in this case, the member will fail. Okay. So effective length. Effective length, maybe this is a new term for us. We know the length. So if I have a member between the 2 points here, I can say this is the length of the member. So what is the effective length? Effective length, this is when I have a member under compression, the part of the member or part of the length of this member to give me half of the sine curve, half of it, this will be my effective length. Look at this case here, pin to pin. The whole member curved. So K will be equal to 1. So effective length for this case, it will be the whole length. But if I have the member fixed from the two sides, in this case, you will find at the start, the member will not be bended. At the end, will not be bended, but half of it will be curved. This is why we consider effective length in K, in this case, will be equal to 0.5. case of fixed in one point and the pin in another point. So you will see that the bending happened not all the way, close to the end, it's straight now, but while about 70% of the member is curved. But if I have a member like last one, fixed to free, if I wanted to get half of sine wave, so I need this curve to be twice. This is why K will be equal to 2. It's very important for us to know that the effective length will be based on the way we fix the member or the way we support the member. Let's see the different cases. As I said, Euler for today, because as I said before, we did last week tension, and we know squash will be, squashing the member will be similar to the tension, so I'm not going to repeat what we did last week. So today we'll concentrate on how to use Euler to calculate or to check your member that under a compression axial load. Let's see first case here. If I have the material and I have effective length and I have the cross-section property, which is the moment of inertia, in this case, Euler can help me to find what is the maximum load. If I know the maximum load, this will tell me later if my member is safe or not. So in this case, if I have all these given, I can determine what is the maximum load I can apply to this member. This is one of the case. Again, Euler will stay with us for another case. If I have material properties E, and I have the effective length LE, and I have the force, so Euler can help me to determine, if you look at the equation here, you have the load, you have E, you have L, so you can calculate what is the minimum value of I. In the following weeks, we are going to give you a special lecture about how to calculate the value of I, so maybe you will notice later, I'll give you the value of I directly, but there is a special session to calculate I. Another case, what about if I have the effective length, I have the cross-section properties, I, and I have the load. So in this case, I can calculate what is the minimum value of E. And the minimum value of E will tell me which material I can select. So you say, for example, if I check the tables now, I need material has 150 gigapascal. So if I need this material and check the tables, I will not find any material exactly 150 gigapascal. So what I'll do, I'll try to see a material higher. If I check steel, for example, it will be 200 gigapascal. If I check aluminum, it will be 70 gigapascal. So in this case, I can't take aluminum. It's 70, I need 150, but I'll take steel, or steel, yes, because steel is higher than the minimum I need. Still, we have Euler. In this case, what if I have the material property E, I have the cross-section property I have the force. This will tell me what is the maximum length I can have for this member. Because if the length will increase, the load will be above the limit. So in this case, I will not be able to carry the load and the member will start to buckle. Last case here for Euler. If I have, in this case, if I have the material property E, and I have the effective length, I have the cross-section property I have even the load. So what I have to do as a designer, in this case, you are going to check, is this load safe or not safe? So this is, if you have all information, you can compare if the load you have comparing to Euler, if your actual load is higher than Euler, that's meaning this member is not safe. If your actual load is smaller than Euler, so your member is safe. If your actual load is exactly equal to Euler calculation, you are just safe. That's meaning this is critical value. The condition all the time, you need the load, the actual load, to be smaller than or equal to B Euler. I think a numerical example can summarize all this story when we do it together. So we have a material property given to us, or we have a case. From this case, what we have a load, this load, compression load, 10 kilonewton, member length 1 meter, cross section of this member is 10 by 10 millimeter. I of this cross section is 833.33 millimeter to power 4. Yield stress 350 megapascal. Young modulus E 200 gigapascal. And this member is pin-to-pin in support. We want to check, is this member safe or not safe? The load is compression. So in this case, I have to check. Number one, is this this member under tension or compression? So the member now under compression, I have to check two things. First, squashing. Two, buckling. If the member pass both, safe for both, the member will be okay. If the member pass one and fail the other, the member will fail. If the member fail both, definitely fail. So let's see now when I check the squashing. I'm going to calculate the actual stress. So I have force, 10 kilonewton. So because our equation using SI units, so you have to put the forces in Newton, so 10,000 Newton, divided by area. Area is 10 by 10 millimeter square. This will give me 100 megapascal. My actual load or my actual stress now is 100 megapascal. For squashing, I compare based on yield. So if I look at 100 megapascal and the yield stress 350, my stress is less than the yield value. So my actual stress is smaller than yield stress, which is 350. So far, I can say the member is safe. So far, I can say it's okay for squashing. I have now to go to check using Euler the buckling situation. If the member pass buckling, fine, we can say safe. Not pass buckling, we can say safe. We have to bring Euler with us. Don't forget, we have everything. We have the load, we have Young modulus, we have I, we have LE, we have everything. So what I'm going to do, I'm going to check first for this member. The member has E, I, and L. In my example, what is Euler load? Or in another word, what is the maximum compression load for this member to avoid buckling? Euler by square, E 200 giga. So you have to make it SI unit, so 200 megapascal, so multiply by 1,000. I 833.33 millimeter to power 4, divided by L effective. L effective, we said it is equal to KL, and the K, in this case, pin to pin, is 1. So 1,000 millimeter, because we have 1 meter length, 1 K for pin. Don't forget square. This will give me, the value is 1,644.9 Newton. This is the maximum load for this member to carry in compression to avoid buckling. Let's check now, what is our case? Our case, if this is the maximum load, my actual load is 10 kilonewton. I put here the values in kilonewton because I'm not doing the equation now. The equation should be SI unit, but here I can do the comparison based on another unit, which is kilonewton. So Euler says 1.6, 1.600, say 1.7 or 1.65 kilonewton, and my actual load is 10 kilonewton. That's meaning this member is not safe to carry this load. So today we checked how to use Euler to check the performance of the member if the member under axial compression load. Thank you very much for joining the Diploma of Engineering sample class. Next, I would like to welcome Claire Young, a current Diploma of Engineering student who will be sharing her experience with us.
Thank you, Tarek. Hello, everyone. I'm Karin Kong, and I'm from Malaysia. I currently finished my first trimester at Monash College and continuing to study for the second trimester in my home country. This pandemic has changed our learning mode, and I wanted to share my experiences while studying online. There are enjoyable tools in the virtual classroom, such as digital whiteboard, screen sharing, and emoji reactions. Videos, readings, and lecture slides can be reached everywhere in Moodle Learning Management System when we wish to refresh our knowledge. Quizzes attached in active learning platform can assess the contained knowledge during lecture classes. And there are drop-in sessions or consultations will be held once or twice a week. I had completed one group assignment in the last trimester. For preparatory mathematics, we had to prepare a group presentation. Since our group members are from different countries and considering different time zone. To collaborate, my two group members and I discussed through Gmail and Instagram to divide our responsibilities and help each other with the work. This assessment taught me how to communicate with others and work well in a team. I participated in the Diploma of Engineering Part 2 focus group, where I was able to share my feedback on the virtual classroom learning environment. There are also many student engagement, social activities, and online clubs, such as cooking club, online games club, and more, which enables us to get connected with each other. I've developed friendships with like-minded people from all over the world. It improves my confidence level, and I've developed communication skills. It gets hard to make friends online, so I will send private messages to some familiar faces who have attended the same classes. We get to know each other by sending emails and through breakout rooms, which are organized by teachers. We will discuss homework questions when facing difficult problems and keep in touch via social media platforms. What the future holds. My destination degree is Bachelor of Engineering. Diploma has helped me a lot, which improved my time management skills and as well as familiarize with Moodle learning system. I'm getting used in the virtual classroom environment, but still hoping to go back to the campus for the actual experiences. The diploma also helped for a faster and more focused way to qualify. Talking about career plans, I'm passionate in finding ways to resolve environmental issues. So my career plans are likely to become an environmental engineer. Thanks for listening and staying with me.
Thank you very much, Kang Young, for sharing your experience with us. It's great to hear that you have been enjoying your time at Monash College and have found the virtual classroom fun and engaging. Okay, I just wanted to quickly let you know about our various support services you have access to at Monash College. Our commitment is to support you to achieve your best. This doesn't change regardless of whether we are online through the virtual classes or face-to-face. Even while you are studying online from your home country, you will still have access to all the support services available at Monash College to help you along the way. To support you in pursuing your dream of a Monash University education in Australia, we are offering to students who are unable to travel to Australia a 20% study grant of the tuition fee for the intake for the intakes shown here. You can see here we mention term 3 October 2021, semester 1 February 2022, or foundation year semester 1 2022 intakes. For students in China, you have a choice between the study grant or on-campus support in our Monash Overseas Learning Center located in Shanghai. These offers are limited, and if you would like more information, please visit our website. We have a friendly and dedicated student engagement and student services team who organize a range of clubs and societies for you to join to learn new skills and meet students from all around the world. Some of the clubs they offer are music clubs, cooking clubs, game clubs, and lots more. We also have learning and career advisors. So learning and career advisors who you will be able to contact to make sure you are on the right path to Monash University. They can help you with your everyday study and can help you transition smoothly into Monash University. To achieve the best at Monash College, you need to feel supported in all areas of your life. That's why your health and well-being is a priority at Monash College. If you have any problems or concerns, our counselors offer free confidential counseling to help you with your personal, academic, and emotional challenges. And of course, the teachers are wonderful and are dedicated to helping you achieve your best. We are also very excited to introduce our brand new vertical campus, which will be opening soon. Set across 10 stories with more than 130 inspiring, flexible learning spaces. The Dockland campus is designed to foster collaboration and innovation between students and teachers. Located in a harbor front and only minutes from the CBD, you will be close to everything Melbourne has to offer, including public transport, restaurants, shopping, parkland, sporting facilities, tourist attractions, and more. I would like at the end to thank you again for joining. We hope this has given you a better understanding of what studying in the virtual classroom is like at Monash College. If you would like some more information about Monash College Pathway programs, please visit our website. The 2022 course guide is also available on our website. If you would like to attend another virtual class room session like this one, please scan the QR code. If you have any question, send them to marketing@monashcollege.edu.au and you will receive an answer as soon as possible. Also, please follow us on our social channels to see what activities you may be able to get involved in while at Monash College. Thank you for joining. We hope to see you soon in the virtual classroom at Monash College, as well as in Melbourne, when we can meet face-to-face again very soon. Thank you.